Spring 1915, Dearborn, Michigan. The industrial engineering consensus from Detroit to London was absolute. No manufacturer could profitably control every step of production from raw materials to finished automobiles. European experts dismissed American vertical integration as economic suicide. Traditional automakers like Packard assembled cars from supplier-made parts at a fraction of the investment. Even the Dodge brothers, who had grown wealthy supplying Ford, warned that his expansion plans would bankrupt shareholders. Through the morning mist rising from the Rouge River, Henry Ford surveyed 2,000 acres of bottomland that would challenge everything the automotive industry believed about efficient manufacturing. No supplier networks, no specialized contractors, no dependencies on outside companies for steel, glass, rubber, or power. Ford envisioned iron ore from his Minnesota mines becoming finished automobiles without ever leaving his property. One continuous process from raw earth to rolling wheels. Critics called it Ford's folly. Too big, too expensive, too risky for any single company to manage. But 8,000 miles from European workshops, the most decisive manufacturing revolution in industrial history was about to prove that American industry could control its destiny. Not through connecting with the world, but through commanding every link in the chain. Henry Ford walked the muddy banks of the Rouge River on a cold April morning in 1915, his boots sinking into the soft bottomland that stretched as far as he could see. The 2,000 acres of marshy terrain looked like nothing more than worthless swamp to most observers, but Ford saw something entirely different. Where others saw obstacles, he envisioned the largest integrated manufacturing complex the world had ever known. The established wisdom of industrial manufacturing stood firmly against what Ford was contemplating. Every successful automaker from Detroit to Stuttgart operated on the same proven principle: specialization through supplier networks. Companies like Packard purchased engines from one supplier, transmissions from another, steel from a third, and glass from a fourth. They assembled these components in relatively small facilities, keeping their capital investments low and their operational risks manageable. European automotive engineers had refined this approach over decades, creating intricate networks of specialized suppliers that fed the growing automobile industry. John and Horace Dodge represented this conventional wisdom better than anyone. The brothers had built their fortune supplying Ford with transmissions and engines, operating from their own focused facility in Hamtramck. Their business model was elegant in its simplicity: become exceptionally good at making one type of component, then sell that expertise to multiple automakers. They employed skilled craftsmen who understood every nuance of transmission manufacturing, maintained relationships with trusted steel suppliers, and generated steady profits without the massive capital investments that full integration would require. But Ford had grown increasingly frustrated with the limitations of supplier dependency. When his production schedules demanded faster delivery, suppliers couldn't always respond. When he needed modifications to improve quality or reduce costs, suppliers resisted changes that might disrupt their own operations. Most critically, when Ford wanted to drive down prices to make automobiles affordable for ordinary Americans, suppliers pushed back because lower component prices meant lower supplier profits. The automotive industry's financial experts had run the numbers repeatedly, and their conclusion was unanimous. Vertical integration beyond final assembly was economic suicide. The capital requirements alone seemed prohibitive. Building an integrated facility would require steel mills capable of producing thousands of tons daily, glass plants using the latest continuous process technology, tire factories with vulcanization equipment, power stations generating enough electricity for an entire city, railroad systems to move materials internally, and even rubber plantations in South America to ensure raw material supplies. European engineers scoffed openly at Ford's emerging plans. They had spent centuries perfecting manufacturing systems based on specialized guilds and supplier relationships. German automotive companies worked with steel suppliers whose expertise dated back generations. British manufacturers relied on electrical component suppliers who had refined their craft through decades of experience. French automakers purchased glass from suppliers whose techniques had been developed through years of experimentation. The idea that one American company could master all these disciplines simultaneously seemed absurd to engineers trained in European traditions. Ford's own financial advisors warned him about the risks. Traditional automaker investments required perhaps $10 million to establish assembly operations. Ford's integrated vision would consume 10 times that amount, with no guarantee of success. If the experiment failed, Ford Motor Company could face bankruptcy, taking with it the jobs of thousands of workers and the investments of countless shareholders. The Dodge brothers watched Ford's early planning with growing alarm. As major shareholders in Ford Motor Company, they had profited handsomely from Ford's success with the Model T, but they also operated their own Dodge Brothers Motor Car Company, which depended on the supplier-based manufacturing model that Ford seemed determined to destroy. If Ford proved that vertical integration could work, it might render specialized suppliers like the Dodge operation obsolete. More immediately, Ford's massive capital investments in integration would reduce the dividend payments that Ford Motor Company could make to shareholders, like themselves. In May of 1916, the Dodge brothers filed suit against Ford Motor Company, claiming that Ford's expansion plans were reckless and that his policy of reducing automobile prices diverted money that rightfully belonged to shareholders as dividends. The lawsuit exposed the fundamental conflict between Ford's vision and conventional business wisdom. The Dodges argued that Ford's primary obligation was maximizing shareholder returns, not pursuing grandiose experiments in industrial organization. Ford's response revealed the depth of his commitment to vertical integration. He testified that his goal was not maximum profits for shareholders, but maximum benefit for society through affordable automobiles. This required controlling every aspect of production to eliminate inefficiencies and reduce costs. He could not achieve this goal while depending on suppliers whose interests might not align with his vision. Construction of the Rouge Complex began on April 1, 1917, even as the lawsuit continued through the courts. The timing could hardly have been worse. America's entry into World War I created immediate competition for materials, workers, and transportation capacity. The U.S. Navy needed steel for warships, creating shortages that drove prices higher. Construction workers were drafted for military service or lured away by higher wages at munitions plants. Railroad capacity was redirected toward moving military supplies, rather than construction materials for private companies. Cost overruns mounted quickly as Ford competed with military contractors for everything his project required. Steel prices doubled, then tripled as war demand overwhelmed supplier capacity. Skilled construction workers commanded premium wages as labor shortages intensified. Transportation delays became routine as military shipments received priority over civilian projects. Critics in Detroit's automotive community began calling Ford's project Ford's Folly. The combination of wartime shortages, massive cost overruns, and the uncertain outcome of the Dodge lawsuit made Ford's vertical integration experiment look like dangerous overreach. Even Henry Ford's closest associates privately questioned whether one man could successfully manage an operation of such staggering complexity while simultaneously fighting a legal battle and competing with the military for essential resources. The stakes extended far beyond Ford Motor Company's success or failure. If Ford's experiment collapsed, it would validate the established wisdom that specialization and supplier networks represented the optimal approach to industrial organization. American manufacturing would continue following European models based on distributed production and specialized suppliers. But if Ford succeeded, he would prove that American industry could control its own destiny through complete vertical integration, from raw materials to finished products, without depending on external suppliers who might prioritize their own interests over efficiency and affordability. By 1920, the first massive structures of the Rouge Complex began rising from the Michigan bottomland like steel monuments to American industrial ambition. The sheer scale defied comprehension even for experienced construction workers who had built Detroit's largest factories. The main assembly building alone stretched more than a mile long, its roof supported by steel girders that required specialized railroad cars to transport from the on-site steel mill. Workers could stand at one end of the factory floor and barely make out human figures at the opposite end through the industrial haze. Ford's breakthrough came through what he called synchronized precision, the coordination of every manufacturing process so that raw materials flowed seamlessly from one operation to the next without pause for storage or handling delays. The concept seemed simple, but executing it required engineering solutions that no manufacturer had ever attempted. Ford installed a mammoth power plant that began operation in 1920, furnishing all the Rouge's electricity needs and supplying one-third of the power required by his Highland Park facility 12 miles away. The power station consumed trainloads of coal daily, its smokestacks visible from downtown Detroit, announcing to the world that American industry was operating at unprecedented scale. The heart of Ford's system was the Great Lakes shipping operation that connected his Minnesota iron ore mines directly to the Rouge's blast furnaces. Ford had purchased 16 coal mines in Kentucky and West Virginia, 700,000 acres of timberland in Michigan and Wisconsin, and iron ore deposits near Lake Superior. But owning raw materials was only half the challenge. Ford needed to transport those materials to his factory more efficiently than any competitor could purchase similar materials from suppliers. The engineering solution required widening the Rouge River itself to accommodate lake freighters that could carry 8,000 tons of iron ore in a single voyage. Ford's construction crews dredged the river channel, built massive concrete docks, and installed unloading equipment that could empty a freighter's cargo hold in less than 8 hours. When the first ore boat arrived at the Rouge docks in 1921, it carried more iron ore than most steel companies processed in an entire month. Ford's blast furnaces began operation with specifications that impressed even European steel experts. Each furnace could produce over 400 tons of molten iron daily, using coke produced in Ford's own ovens from coal mined in Ford's own mines. The molten iron flowed directly into Ford's steel mills without cooling and reheating, an efficiency improvement that eliminated the energy waste that plagued traditional steel operations. By 1922, Ford was producing steel more cheaply than specialized steel companies could sell it. The glass plant that opened in 1923 represented Ford's most innovative technical achievement. Working with engineers from the Libby Owens Sheet Glass Company, Ford developed a continuous glass production process that eliminated the traditional batch methods used by glass suppliers. Molten glass flowed in an unbroken stream from furnaces through cooling chambers to cutting stations, producing window glass of consistent thickness and clarity. The process reduced glass production costs by 40% while improving quality beyond what traditional glass suppliers could achieve. Ford's rubber operation extended his vertical integration to South America, where he purchased 2.5 million acres of Amazon rainforest in Brazil for rubber plantations. The Fordlandia project aimed to produce all the rubber Ford needed for tires and automotive components without depending on British-controlled rubber plantations in Southeast Asia. Though the Brazilian operation faced tropical diseases and worker unrest, it demonstrated Ford's commitment to controlling every raw material his automobiles required. The Rouge's internal transportation system rivaled many American cities in complexity and efficiency. 120 miles of conveyor belts moved materials between operations, synchronized with the production schedules of each department. Railroad tracks crisscrossed the complex, connecting blast furnaces to steel mills to parts manufacturing, and parts manufacturing to final assembly. Ford employed more locomotive engineers and railroad workers than some actual railroad companies, operating a transportation network entirely within his factory walls. Workers who had spent their careers moving between different automotive suppliers found themselves part of an integrated system unlike anything in American industry. Steel workers who once sold their products to various automakers now saw their steel transformed into car components in the same complex where they worked. Glassworkers watched their window glass installed in automobiles rolling off assembly lines visible from their production stations. The psychological impact of this integration created a workforce mentality that Ford's competitors could not replicate through supplier relationships. The Rouge's machine shops produced components with precision that amazed automotive engineers. Ford installed the latest American machine tools, capable of manufacturing parts, to tolerances measured in thousandths of an inch. But more importantly, Ford controlled the entire process from raw steel to finished component, eliminating the quality variations that plagued automakers who assembled parts from multiple suppliers. When Ford's engineers detected problems with component specifications, they could adjust the steel composition, modify the machining operations, and test the results within the same facility. By 1925, The Rouge Complex employed over 75,000 workers in an operation that functioned like an industrial city. Ford built a fire department with multiple stations, a police force to maintain order, a fully equipped hospital to treat industrial accidents, and a maintenance crew 5,000 strong to keep the massive machinery operating around the clock. The complex consumed as much electricity as a city of 500,000 people and used more water daily than many American states. The competitive advantages became undeniable as production statistics accumulated. Ford's integrated system eliminated the coordination problems that plagued other manufacturers, who struggled to synchronize deliveries from dozens of suppliers. Traditional automakers faced constant delays when suppliers missed delivery schedules or delivered components that failed quality inspections. Ford's vertical integration meant that every component arrived at the assembly line precisely when needed, in the exact quantities required, meeting quality standards controlled by Ford's own operations. European automotive experts who visited the Rouge returned to their home countries with reports that challenged everything they believed about efficient manufacturing. German engineers who had praised their own supplier networks found themselves struggling to explain how Ford achieved both lower costs and higher quality through vertical integration. British manufacturers discovered that their traditional supplier relationships actually created inefficiencies that Ford's integrated approach eliminated. The Rouge had become proof that American industrial methods could surpass European expertise through scale, integration, and systematic coordination rather than traditional craftsmanship and supplier specialization. The Rouge achieved the distinction of automotive ore-to-assembly in 1927 with the long-awaited introduction of the Model A. Ford had halted Model T production 6 months earlier, retooling his entire operation for a completely new automobile, while his competitors seized market share with updated designs. The gamble was enormous. Ford shut down the world's most efficient automobile factory to prove that vertical integration could adapt faster than supplier-dependent manufacturers could respond to changing consumer demands. The morning of October 20th, 1927, marked the moment when Ford's vision achieved perfect mechanical poetry. At exactly 7:32, the first Model A Ford rolled off the Rouge assembly line, its steel forged from ore that had arrived by Lake Freighter just 72 hours earlier. Every component in that automobile, from the laminated safety glass windshield to the rubber tires to the electrical system, had been manufactured within the Rouge complex using raw materials owned and transported by Ford Motor Company. The production rhythm that emerged exceeded every prediction Ford had made to skeptical investors and engineers. One new Model A Ford rolled off the assembly line every 49 seconds during peak production periods. Each day, workers smelted more than 1,500 tons of iron ore into steel, produced 500 tons of glass using Ford's continuous process, and manufactured thousands of individual components with precision that traditional suppliers struggled to match. The Rouge had become a manufacturing machine of unprecedented efficiency and scale. Ford's competitive advantage became mathematically undeniable when the Model A reached dealerships with a base price of $395. Competitors using traditional supplier networks could not match Ford's combination of quality and affordability. Chevrolet's comparable model cost $50 more while offering fewer features. European imports cost twice as much and required months for delivery. By eliminating supplier profits and transportation costs between multiple facilities, Ford achieved pricing that forced competitors to sell automobiles at losses or abandon market segments entirely. The Model A's technical specifications demonstrated how vertical integration translated into product superiority. Ford's laminated safety glass windshields, the first used in any low-priced automobile, resulted from his continuous glass manufacturing process that eliminated the quality variations plaguing traditional glass suppliers. The Model A's steel body panels showed uniform thickness and consistent strength because Ford controlled every step from iron ore to finished metal. Even the automobile's electrical system reflected integration advantages, with generators and batteries manufactured to specifications that perfectly matched the Model A's power requirements. European manufacturers watched Ford's achievements with growing alarm as their own supplier-dependent operations revealed fundamental disadvantages. German automakers discovered that their praised supplier networks created coordination problems that Ford's integration eliminated entirely. When German engineers needed component modifications to improve performance, they faced negotiations with multiple suppliers whose interests might conflict with design improvements. Ford's engineers simply walked to the appropriate department within the Rouge Complex and implemented changes immediately. The Rouge's internal logistics reached levels of sophistication that impressed visiting industrial engineers from around the world. Raw materials moved through the complex on precisely timed schedules that eliminated every unnecessary handling operation. Iron ore traveled from lake freighters to blast furnaces on conveyor systems that operated continuously without intermediate storage that would require additional handling. Molten steel flowed directly from furnaces to rolling mills to parts manufacturing without cooling and reheating cycles that wasted energy and time. Ford's achievement in eliminating inventory represented a breakthrough that modern manufacturers would not fully understand for decades. Traditional automakers accumulated large stockpiles of components to prevent assembly line stoppages when suppliers experienced delays. But stockpiling tied up enormous amounts of capital in parts that generated no revenue until installed in finished automobiles. Ford's vertical integration meant that components arrived at assembly stations precisely when needed, in exact quantities required, eliminating both inventory costs and the space required for storage. The human dimension of Ford's integrated system created workforce loyalty that competitors could not duplicate through traditional employment relationships. Workers who might have spent their careers at multiple companies, moving from steel mills to parts suppliers to final assembly operations, now experience their entire industrial careers within Ford's integrated complex. Steel workers saw their work transformed into automobile components by colleagues they knew personally. Assembly workers understood how their efficiency affected the miners in Minnesota, whose ore supplied the Rouge's blast furnaces. By 1929, the Rouge Complex employed more than 100,000 workers in an operation that had achieved complete industrial self-sufficiency. Ford generated his own electricity, produced his own steel, manufactured his own glass, processed his own rubber, and operated his own transportation systems. The complex consumed raw materials from Ford-owned mines, forests, and plantations, transforming those materials into finished automobiles without depending on any outside suppliers for essential components. The Rouge's efficiency measurements revealed advantages that traditional manufacturing experts had declared impossible. Ford's integrated system reduced component transportation costs to zero. Steel traveled from furnace to parts manufacturing on internal conveyor systems rather than trucks and railroads connecting separate facilities. Quality control improved because Ford's engineers could adjust raw material specifications, manufacturing processes, and final assembly procedures within the same organization. Production scheduling became predictable because Ford controlled every variable that affected automobile manufacturing. International recognition of Ford's achievement came from unexpected sources when Soviet industrial planners visited the Rouge to study vertical integration techniques for their own 5-year plans. European automotive companies sent engineering delegations to understand how American methods had achieved efficiency levels that challenged fundamental assumptions about optimal industrial organization. Even British manufacturers who had developed the world's most sophisticated supplier networks acknowledged that Ford's integrated approach offered advantages they could not match through traditional methods. Ford's pricing strategy demonstrated vertical integration's ultimate purpose, making automobiles affordable for ordinary American workers. The Model A sold for little more than $200 by 1930, a price that enabled Ford factory workers to purchase the automobiles they manufactured. This created an economic cycle that benefited both Ford Motor Company and American consumers. Higher wages for Ford workers meant larger markets for Ford automobiles, while lower automobile prices meant higher living standards for American families. The Rouge had proven that American industry could achieve complete independence from supplier networks while delivering superior products at lower costs than specialized suppliers could match. Success bred overconfidence in Henry Ford's industrial empire by the mid-1930s. The Rouge Complex had proven that vertical integration could deliver automobiles more efficiently than any supplier-dependent manufacturer, but Ford's methods of controlling his integrated workforce had grown increasingly authoritarian. While other American companies negotiated with emerging labor unions, Ford maintained absolute control through Harry Bennett's Service Department, a private security force that operated more like an industrial army than a personnel organization. Bennett had transformed Ford's employee relations from paternalistic generosity into systematic intimidation. The former boxer recruited enforcers from Detroit's underworld, hiring ex-convicts and street fighters who used violence and surveillance to suppress any worker organizing that might threaten production efficiency. Ford's $5 a day wage policy, revolutionary in 1914, had become outdated by the Depression years, but Bennett's methods prevented workers from demanding improvements through collective bargaining that other industrial workers were achieving. The United Auto Workers Union had successfully organized General Motors and Chrysler through sit-down strikes that captured public sympathy, but Ford's Rouge Complex remained a fortress of anti-union resistance. Bennett's men infiltrated union meetings, photographed workers who attended organizing rallies, and maintained blacklists that prevented union sympathizers from finding employment anywhere in Ford's operations. The Rouge's integrated efficiency depended on worker cooperation, but Ford was maintaining that cooperation through fear, rather than the mutual benefit that had originally motivated his workforce. Walter Reuther emerged as the UAW's most articulate spokesman for organizing Ford's workers, combining intellectual arguments for industrial democracy with practical organizing skills that had proven effective at other automotive companies. Reuther understood that Ford's vertical integration actually strengthened workers' bargaining position. If Rouge employees could halt production, Ford could not rely on supplier relationships to maintain automobile manufacturing while resolving labor disputes. But organizing Ford's workers required confronting Bennett's security apparatus directly. The confrontation came on May 26, 1937, when Reuther and other UAW organizers planned to distribute union literature at the Miller Road overpass near Gate 4 of the Rouge Complex. The overpass was legally public property, where union organizers had the right to speak with Ford workers during shift changes. But Ford and Bennett viewed any union presence near the Rouge as a threat to the integrated system that depended on unquestioned worker compliance. At approximately 2 o'clock that afternoon, Reuther arrived at the overpass with an entourage that included clergymen, representatives from the Senate Committee on Civil Liberties, and dozens of women from UAW Local 174. The delegation was carefully chosen to demonstrate that union organizing represented mainstream American values rather than radical threats to industrial order. Reuther wore a business suit and carried only union literature, presenting himself as a reasonable negotiator rather than a revolutionary agitator. James Kilpatrick of the Detroit News positioned himself with his camera to document whatever occurred, understanding that photographs could influence public opinion more effectively than any written account of the confrontation. Kilpatrick had covered Detroit's industrial conflicts for over a decade, but he sensed that this confrontation would determine whether American workers could organize in the face of corporate resistance that employed systematic violence. Bennett's men had been waiting for this moment, positioned strategically around the overpass to surround union organizers once they arrived. The Ford security forces included not only company employees, but also members of Detroit's underworld who owed Bennett favors from his connections to illegal gambling and liquor operations. These men understood that their assignment was not crowd control, but the physical destruction of union organizing through calculated brutality. The attack began without warning when Bennett's forces surrounded the union delegation. Reuther later testified that 7 times they raised him off the concrete and slammed him down on it, pinning his arms while he was punched and kicked and dragged by his feet to the stairway, then thrown down the first flight of steps, picked up, slammed down on the platform, and kicked down the second flight. The violence was systematic and deliberate, designed to inflict maximum physical damage while demonstrating to other Ford workers the consequences of union involvement. Kilpatrick's camera captured the brutality with shocking clarity, as Bennett's men beat not only Reuther, but also the clergymen and women who had accompanied the union delegation. In total, 16 unionists were injured in the attack, including 7 women whose beatings particularly outraged American public opinion. The photographs showed Bennett's men kicking unconscious union organizers and attacking women who posed no physical threat to anyone. The images that appeared in newspapers across America the next morning transformed public perception of Ford's labor relations overnight. Americans who had admired Ford's industrial achievements suddenly saw his Rouge Complex as a symbol of corporate tyranny that used violence against workers exercising constitutional rights. The photographs proved that Ford's integrated efficiency came at a human cost that violated American principles of democratic participation and worker dignity. The Battle of the Overpass exposed the fundamental contradiction in Ford's vertical integration strategy. While Ford controlled every aspect of automobile production, from raw materials to finished products, he could not control public opinion through the same authoritarian methods. The Rouge's technical efficiency became irrelevant when Americans viewed Ford Motor Company as an enemy of worker rights and democratic values. Production at the Rouge began suffering almost immediately as the controversy spread. Workers who had previously accepted Bennett's intimidation now saw Ford's security apparatus as vulnerable to public criticism. Slowdowns and minor acts of sabotage disrupted the precise coordination that made vertical integration profitable. Ford's competitive advantage evaporated as labor unrest spread throughout the complex, proving that even the most integrated manufacturing system required willing worker cooperation. The crisis threatened everything Ford had built over 2 decades of vertical integration development. His integrated empire had proven it could control raw materials transportation and manufacturing processes, but it could not control the human element that made industrial efficiency possible. Ford's heavy-handed labor relations had transformed willing workers into resentful opponents, whose resistance could destroy the coordination advantages that vertical integration required. The Rouge Complex had achieved technical perfection in transforming iron ore into automobiles, but Ford's authoritarian control methods had created human problems that no amount of industrial integration could solve. Ford eventually recognized the United Auto Workers in 1941, but it was World War II that provided the ultimate vindication of vertical integration's strategic value. When President Roosevelt called for America to become the arsenal of democracy, the Rouge Complex demonstrated advantages that no supplier-dependent manufacturer could match. The same integrated system that critics had called inefficient in peacetime became essential for wartime production speed and flexibility. The transformation began within weeks of Pearl Harbor when military procurement officers arrived at the Rouge with urgent requirements for jeeps, aircraft engines, tank components, and amphibious vehicles. Traditional manufacturers faced months of delays while coordinating with suppliers to retool for military production, but Ford's integrated operations could pivot almost immediately. When the Rouge's steel mills needed to produce armor plate instead of automobile bodies, Ford's engineers simply adjusted furnace temperatures and rolling mill specifications. When aircraft engine production required aluminum components, Ford's purchasing department sourced raw aluminum, and Ford's machine shops began manufacturing precision parts within days. The Rouge's aircraft engine production showcased vertical integration's ultimate potential. Ford committed to manufacturing Pratt & Whitney R2800 double wasp engines for Republic P-47 Thunderbolt fighters and Douglas A-26 Invader bombers. The 18-cylinder radial engines required manufacturing precision that challenged even aircraft specialists, with component tolerances measured in 10,000ths of an inch and metallurgical specifications that demanded perfect consistency across thousands of parts. Ford's integrated approach revolutionized aircraft engine manufacturing by applying automotive mass production techniques to precision aerospace components. The Rouge's steel mills produced engine block materials to exact specifications, eliminating the quality variations that plagued suppliers working with multiple customers. Ford's machine shops manufactured crankshafts, cylinder heads, and precision bearings using techniques developed for automobile engines but refined to aircraft standards. Most importantly, Ford's integration eliminated the coordination delays that crippled other aircraft engine manufacturers who depended on dozens of specialized suppliers. Within 18 months of Pearl Harbor, the Rouge was producing one complete aircraft engine every hour during peak production periods. Ford manufactured over 57,000 double wasp engines during the war, more than any other single facility, and with quality ratings that exceeded engines produced by traditional aircraft manufacturers. The Rouge's integration advantages meant that Ford could implement design improvements immediately across all components, while supplier-dependent manufacturers needed months to coordinate changes among multiple companies. Ford's Jeep production demonstrated how vertical integration could achieve impossible delivery schedules when national survival depended on speed. The U.S. Army needed lightweight, reliable vehicles for reconnaissance and communication, but existing manufacturers lacked capacity to meet military requirements quickly. Ford's Rouge Complex could manufacture Jeeps using steel from Ford's mills, glass from Ford's plants, rubber from Ford's Brazilian plantations, and electrical components from Ford's suppliers, all coordinated within a single integrated operation. The Rouge produced over 277,000 Jeeps during World War II, establishing manufacturing techniques that other companies could not duplicate through supplier relationships. Ford's integrated quality control meant that every Jeep met military specifications exactly, while competitors struggled with component variations from multiple suppliers. Ford's integrated logistics meant that Jeep production could increase or decrease based on military requirements without renegotiating contracts with dozens of separate companies. But Ford's most significant wartime contribution came through manufacturing amphibious vehicles that required unprecedented coordination between automotive and maritime engineering. The WWII amphibious truck combined truck chassis, marine propellers, and waterproofing systems in a single vehicle that could operate on land and water. Traditional manufacturers would have required separate contractors for automotive components, marine systems, and waterproofing technology, creating coordination problems that could have delayed production for months. Ford's vertical integration eliminated these coordination problems entirely. The Rouge's automotive engineers worked directly with Ford's marine specialists to design chassis modifications that accommodated waterproofing requirements. Ford's steel mills produced specialized alloys that resisted saltwater corrosion while maintaining structural strength. Ford's rubber operations developed gaskets and seals that prevented water infiltration under combat conditions. The WKW project succeeded because Ford controlled every aspect of development and manufacturing within the same integrated organization. The Rouge's wartime production statistics revealed vertical integration's decisive advantages under extreme pressure. During peak wartime production, the complex employed over 120,000 workers producing military equipment around the clock. Ford manufactured Jeeps, aircraft engines, tank engines, amphibious vehicles, aircraft components, tires, and armor plates simultaneously, switching production emphasis based on military priorities without the delays that plagued supplier-dependent manufacturers. European manufacturers who had survived Axis occupation marveled at American integrated manufacturing when they visited the Rouge after the war. British automotive engineers discovered that their traditional supplier networks, praised before the war for flexibility and specialization, had created vulnerabilities that Ford's integration eliminated. German industrial planners studying American methods found that vertical integration provided strategic advantages they had never considered during their pre-war expansion. The contrast with modern manufacturing vulnerabilities became starkly apparent decades later, when supply chain disruptions revealed the fragility of supplier-dependent systems. While contemporary automotive plants faced complete shutdowns when single suppliers experienced problems, Ford's Rouge had demonstrated that controlling the entire production chain provided resilience that no network of external relationships could match. The same integration that peacetime critics called excessive became essential when rapid adaptation meant the difference between victory and defeat. Ford's wartime success validated every argument he had made about industrial self-sufficiency since 1915. The Rouge Complex had proven that American industry could achieve complete independence from suppliers while delivering superior products faster than any competitor. Vertical integration was not corporate excess, but strategic necessity, the foundation of industrial power that could adapt to any challenge while maintaining control over its own destiny. The Rouge's wartime performance established the template for American industrial supremacy that would dominate global manufacturing for decades. Ford had proven that controlling every link in the production chain was not about isolation, but about the ultimate expression of industrial capability and national strength.